So thank you, Dr. Mamanis, for the excellent presentation and in-depth presentation. I'll request you share the slide so that we can be passing on to the researcher who are doing research in this area. And
Okay.
I'll request Bharat Jyoti to give a vote of thanks.
Should I send you with email after
Yes.
Okay.
Yes.
Okay.
Bharat, can you
Bharat,
propose
you
a
are
vote
there?
of thanks?
Bharat
Or,
is not
yeah,
listening. Yeah.
Dr. Patnaik, you are giving?
No, Bharat is there. Bharat is there.
Okay, Bharat. Thank you, Dr. Mamanis, again. And whenever you visit India, please let us know. We'll invite you to our university.
Okay, thank you very much.
Thank you.
Thank you.
Namaste. Namaste.
Thank you very much.
Bye. Good afternoon.
Thank you. Bye.
The meeting is end now. So we have another talk with another link. So we'll be joining very soon. Thank you all.
Thank you.
we are unable to invite them. Maybe say, next year we'll definitely invite them. And also, if the opportunity comes, we'll be love to invite you to India.
I went to, I actually work with University of Mumbai, and I have several students from India, and I give a workshop in Mumbai in 2018 before the pandemic and stuff like this. So I used to work with universities in India and giving workshops, talks. So I would love to, but it's so late for you guys and girls. How do
so
you...
the world is very small. The world is very small.
It is, yes. And I mean, I appreciate collaborating with you and Dr. Kunchev.
Yes.
Always is good to work with smart people.
So it is exactly 6:30. Let me start formally inviting you. And before that, madam, I want to just introduce my university. A few lines, then I'll introduce you. For your knowledge, I must tell my university name is Sikkha O Anusandhan University. It is a local name, provincial language name. It means the technical education and research. The name is Technical Education and Research.
Okay.
And the founder is one of the electrical engineering professor. Previously, he was working as a professor in one of the local university in the same city of Bhubaneswar. And he quit his job in 1996 to set up one engineering college with 120 seats. And gradually it has emerged as a vast university, and it announced as a university in 2007. And now it is in the within 50 rank inside India, doing wonderful progress. We are it is a dependable educational institute for the career building of the graduate students. We have branches like engineering, medical, dental, law, agriculture, pharmacy, veterinary, and whatnot. Other branches also, biotechnology, bioengineering. We are into, say, research, teaching, as well as social service. We have our own printing house. We have our own media house. And we do wonderful job in the city of Bhubaneswar and in my province of Odisha. So that's how we are doing. And we invite one delegate from outside India each month. So month of April, Professor Kunchev was our guest. And for the month of July, you are our guest.
Thank you so much.
Our faculty member, as well as the doctoral students, as well as the MTech students, they will be listening to you. So that all we are about. And now I must formally introduce Professor Mariofanna Milanova. He is a professor of computer science department at the University of Arkansas at Little Rock since 2001. She received her MSc in Expert System and Artificial Intelligence and PhD in Engineering and Computer Science from Technical University of Sofia, Bulgaria. Dr. Milanova conducted doctoral research in visual perception at University of Baden-Württemberg, Germany. Dr. Milanova has her extensive academic experience at various academic and research organizations worldwide. She is a IEEE senior member, Fulbright US scholar, and NVIDIA Deep Learning Institute University ambassador. Dr. Milanova works is supported by National Science Foundation, National Institute of Health, DARPA, DOD, Homeland Security, NATO, Nokia Bell Lab, New Jersey, USA, and Nokia, Finland. She has published more than 120 publications, over 52 journal papers, and 32 book chapters, and numerous computer conference papers, and has 2 patents. Her expertise in the area of artificial intelligence, machine learning, signal, speech, and image and video processing, brain-like computing, and computer graphics. I have heard her 2 times in the workshop on new approaches for multidimensional signal processing organized by University of Sofia, Technical University of Sofia, Bulgaria. It is an excellent she's an excellent speaker. Once you will start, it will, she can goes on speaking and speaking, and our faculty member and MTech student will really enjoy. And there is a career perspective in her talk, and many things we will learn from her. Now the floor is for Madam Milanova.
Professor Shrikant, thank you so much for nice words, and thank you for invitation. Thank you for having me here. So yeah, I don't know. You say the schedule is 2 hours. I think that I can make it shorter, but because you mentioned that you actually listened to talks, and I was thinking to present part of the first talk and the second. So I will present both. But
okay.
You have
no. It is not compulsory to take 2 hours. You are comfortable to take 1 hour, and goes on. If it is goes on, you can extend more. So don't worry about that. Yeah.
This is what we have to do, and please don't hesitate. Stop me. I will. I usually put one screen to work, and another I can see if you have a questions. Stop me at any time. So let me see if we can. Okay. To check first. Okay, because this is not so good. Let me see. No? I'm just checking if you are seeing okay, because I want to have you guys in one screen and the presentation is in another screen. It's okay?
Yes, it is okay. You have to just make it full screen.
If I make a full screen, I cannot see you because both of screens are covered.
Okay. It is fine.
No
it is fine.
No problem.
Yeah, so only this is the reason that I'm not doing, because otherwise is hidden. Okay. Well, this is actually, wow, what I'm doing. I think that I change it. No, okay. Well, this is from the last year, but so yes, I will tell you a little bit about Little Rock. It's a very beautiful place, and I would like to invite you here too, and we can do the collaborative work. And like I say, even we accept students. We have a joint program, master, 2 years in India, 2 years with us. It's a beautiful state. If you, everybody knows Clinton, this is the place that Bill Clinton is born. So, like you understand from my bio, actually my main interest is visual perception and visual intelligence. So, this is the picture that everybody see every day, and in India even is worse, I know. But 90% of the information that we receive, and this information is coming actually 60,000 times faster than obviously the research in visual perception is huge. And one of the main area that I have is actually attention, visual attention, and visual perception. But we will see the techniques that we're using actually are applicable in different areas. So, well, maybe I can disappoint you a little bit. Dr. Kochev is very technical. I'm not so technical when I present presentations. So I like to have these funny images, and like I say, stop me at any time. So as you can see, we need more friendly computers, or they need more smarter people. And also, I like the sentence of Moravec, that actually whatever is very simple for human is very hard for computer, and what is simple for computer is hard for human. So obviously there is a lot of work to do, and my next topic you will see in the end is actually the future of deep learning. But why I'm giving this talk is because I will talk how you guys can participate in Deep Learning Institute and using all of the opportunities that we have right now from big companies like Google, like NVIDIA, like Microsoft. So I'm sure that you use it already, but I will talk a little bit more in my next presentation. Now, and because this is the reality, artificial intelligence, some people reject it. I don't know what is your opinion, and I will be so happy to discuss with you. Even in my state, in my city, Little Rock, even young people don't accept artificial intelligence, but it's reality, okay? They actually use it every day when they travel, and you know all of this. So before to start with deep learning, in all of the problems in the beginning with computer vision, I just will mention the main task actually that we have. And they are first detecting objects, because we need to detect them, localization, detecting. We need to classify them, classification. And we do this with image classification, but there is a difference between the semantic segmentation when you differentiate the objects in the scene, but the more interesting is instant segmentation, because we don't only differentiate objects, but we count them, how many of them there are in the environment. So the main task, of course, is to figure out how we can see like a human. And this is not new. This is the very old task, actually. I will give you the presentation, and there are very interesting links. I will show you some of them, but I will give you the presentation. So my work, I was very fortunate, and very happy to work on several projects. One of the first projects in my postdoctoral research in Germany was to simulate human vision. And I work for company, auto company, but in Paderborn University, but they didn't say it's self-driving cars. We do it for robots in this case, okay? So obviously, I studied biological vision, how humans perceive the environment. And you probably know that whatever we accept with our eyes and whatever is accepted in our camera is actually visible state, but it's a projection of hidden state of the environment. Okay, And in 60s, 1954 and 60, Barlow suggests that the low-level vision system is using prior knowledge, obviously, in our brain, and trying to reduce the dimensionality or trying to find the statistical properties of the signals in the environment. Okay, so this is what actually our brain needs to do. What we are trying to do is simulating this kind of models that analyze the images or video that we perceive. So this is in general, no? But because my task is unsupervised, this become more difficult in our, when you will see a little bit about the brain. So this is the theory that we used before, that using different kind of filters, and your university is mostly engineering university, so most likely I don't need to explain how the convolution filtering and any of these topics that are signal processing topics. So the image is actually linear composition from basic functions or kind of filters that we apply and multiply by coefficients of different kind of filters, different kind of coefficients. And this work we did many years in the different universities, and you are probably familiar with all of these filters that we can apply, like Fourier transform, like histogram-oriented gradient, like principal component analysis, and so on, extracting features. So now we want to create something that is more close to, to kind of simulating how humans perceive the environment or how they make a decision. But in this case, it's on how they perceive the environment. So artificial intelligence is a big area, and this is why people are so confused. They are also disappointed. So when I study, neural network was modern. I also have my teachers like Kuhonen, like Bishop and Wapniak. So in the time, in one time in this 80, actually, people disappointed from neural network and decided that, okay, Tom Michel in machine learning is more rule-based systems and more statistics. You're familiar with these topics. So machine learning could become a very popular, but recently, because of the technology, because of the hardware available, the GPUs and stuff, we start to move to deep learning and become so popular right now that in every article, if there is no deep learning mentioned, they even reject our article. So, okay, what is the difference? The difference is that in machine learning, we have a very hard work to extract appropriate features. And this is what we study and teach our students, that if you don't understand the problem, or you don't have enough data set, or if you don't extract appropriate features, you cannot make a decision, because the models, you're familiar with the regression, support vector machine, all of them are trying to do prediction or classification, but they are using features extracted from us. Okay, so in the when we're seeing the environment, okay, like a child, actually the process of learning is different. The process of learning is that we see many times, and actually not so many for human, to see the child number 2, and when is coming another number, we'll make a decision. So exactly this is the difference that we, and why people love it so much, because they are already pre-trained models to recognize different objects, to recognize text, to translate from English to Hindu or to Chinese. So they are already pre-trained model, and you just use them. No, so the problem we will see. The problem that we need a lot of images or a lot of training data, but it's not necessary manually to extract features. So this is the main difference, as you can see. And everybody, I hope, see this architecture, that we have different layers of representation. Start with low level of feature extracting from the environment, and after that combining with more high level features. And I want to, yes, this is the convolution. If you have a problem, what convolving is, it's very simple process. Like I say, you're familiar with filters and kernels. So from two different data sets, we receive input and output, and we receive a new output data set that is shrinked. So depending what kind of size of kernel we will use. But what I want to show you, I actually have the link here, and I want to show you that these people from California, they create a very good visualization tool. And now I will show you the video, how they extract different pictures.
Recent advances in neural networks have enabled computers to better see and understand the world. They can recognize school buses and zebras and can tell the difference between Maltese terriers and Yorkshire terriers. We now know what it takes to train these neural networks well, but we don't know so much about how they're actually computing their final answers. We developed this interactive deep visualization toolbox to shine light into these black boxes, showing what happens inside of neural nets. In the top left corner, we show the input to the network, which can be a still image or a video from a webcam. These black squares in the middle show the activations on a single layer of a network, in this case the popular deep neural network called AlexNet running in Caffe. By interacting with the network, we can see what some of the neurons are doing. For example, on this first layer, the unit in the center responds strongly to light to dark edges. Its neighbor, one neuron over, responds to edges in the opposite direction, dark to light. Using optimization, we can synthetically produce images that light up each neuron on this layer to see what each neuron is looking for. We can scroll through every layer in the network to see what it does, including convolution, pooling, and normalization layers. We can switch back and forth between showing the actual activations and showing images synthesized to produce high activation. By the time we get to the fifth convolutional layer, the features being computed represent abstract concepts. For example, this neuron seems to respond to faces. We can further investigate this neuron by showing a few different types of information. First, we can artificially create optimized images using new regularization techniques that are described in our paper. These synthetic images show that this neuron fires in response to a face and shoulders. We can also plot the images from the training set that activate this neuron the most, as well as pixels from those images most responsible for the high activations, computed via the deconvolution technique. This feature responds to multiple faces in different locations. And by looking at the decon, we can see that it would respond more strongly if we had even darker eyes and rosier lips. We can also confirm that it cares about the head and shoulders, but ignores the arms and torso. We can even see that it fires to some extent for cat faces. Using backprop or decon, we can see that this unit depends most strongly on a couple units in the previous layer Con4, and on about a dozen or so in Con3. Now let's look at another neuron on this layer. So what's this unit doing? From the top 9 images, we might conclude that it fires for different types of clothing. But examining the synthetic images shows that it may be detecting not clothing per se, but wrinkles. In the live plot, we can see that it's activated by my shirt. And smoothing out half of my shirt causes that half of the activations to decrease. Finally, here's another interesting neuron. This one has learned to look for printed text in a variety of sizes, colors, and fonts. This is pretty cool because we never asked the network to look for wrinkles or text or faces. The only labels we provided were at the very last layer. So the only reason the network learned features like text and faces in the middle was to support final decisions at that last layer. For example, the text detector may provide good evidence that a rectangle is in fact a book seen on edge, and detecting many books next to each other might be a good way of detecting a bookcase, which was one of the categories we trained the net to recognize. In this video, we've shown some of the features of the DeepViz toolbox and a few of the things we've learned by using it. You can download the toolbox at this URL and explore for yourself. If you'd like to share what you found.
Okay. Yep. So you have the link here, and I think that this is really telling you what I will show you. It's happening in the brain, and it's trying to simulate the brain activations of the neurons. So this is what we do with different layers, and we can actually make a segmentation from original image. But like I say, please stop me if you have any questions. This part, what I actually study, is the structure of visual cortex. So from the retina, we're coming to the visual cortex. And actually, maybe in the next picture, you can see better that even for the information that is coming in V1, the visual cortex part, even for one object is separated in the brain in two different areas. This is interesting, that the localization of the objects is processing in one area of the brain, and the shape of the object's color in different areas. This is the interesting. But what the guys show you, and I like that they create this video, because otherwise it's difficult for people to understand that actually Hubel and Wiesel, and I have original video from them, in 1957 demonstrate that the main role of these neurons is to respond to the bars of light with specific angle. And when they respond with the bar of light, like the guy show you, up to specific angle, they actually create the drawing in the brain. Okay, they create the drawing in the brain, what exactly is in the scene, in the environment. So this is the original video from them, but it's kind of noisy, and it's just there is a noise when the neuron is activated. But the video before was very, very good. So I'm giving these presentations because I'm sure that for many people, it's kind of strange to understand these layers and how why we need them and how the neurons learn to activate. But it's really simulation of human brain. So this is from my study. So I've summarized a little bit here because we have several layers. So one is the retina, and retina we simulate before with a difference of Gaussian filters, because they actually, in the next one, you will see in the left side, this is our model, difference of Gaussian filter, and this is the original shape of the neurons. Original shape of the neurons, as you can see, is similar. So after that, we have the primary visual cortex, V1, and they are the real neurons. They also have a shape to react on particular angles, in the environment, and we create these filters using Gabor filter, okay, Gabor filter. But like the guy show you, what we can actually see is after the convolution. Okay, we do the convolution, and after that the deconvolution. So I'm sure that you are familiar with different decomposition techniques, and they are really important because, like I say, the main task is not to create mathematical filters, and this is the difference between my research and Dr. Kunchev's research. He is using wavelet transformations most of the time to decompose. I'm trying to do unsupervised learning, unsupervised decomposition, because like we see in the beginning, we need to find the statistical property of the signals. And these are the filters, like in previous video, you see the different kind of filters extracted using different decomposition techniques. So in my research, I like the this sparse decomposition, and on the base of this sparse decomposition, the similar filters or similar features, similar edges in the scene, in the environment, they are combined, and this is how the drawing in the brain is created. Okay. And for model that I propose is actually using Cohon and MAP, but they are topologically integrated. And these are the links to the papers. So like in the video that I show you, if people, and I have here one artificial bionic eye. So if to see one image or video with good quality, we will need to have all of these basic functions included. Otherwise, we will do the deconvolution with one of the filters, and we will see the environment looks different. No? So I hope it's clear. If you have time, I will show the video actually of how people see. So there are many interesting deep learning models every day. This is kind of representation, but I think that with the video you understand better the different layers, and when we can visualize them. This is very good, by the way, because you can figure out what kind of changes you can make it. So one of the base was this region convolutional neural network. Alex, you see in the video, so you can see they are doing the instance segmentation. Very good. Another one, and so this is the architecture. So they start from the whole image, finding the region of interest, and after that convolving with convolution. Well, the fast one, this fast R, is fast because we do the convolution on the base of the whole image, and after that extract the region of interest. This is the models. We use several models, and we will see in our examples. So this part, region proposal network, is trying to find the regions of interest. So we do the convolution, we extract all of these features, but not like in the face moving, my face or any face moving on the screen. You have a static background. You don't need to extract all of this information. So you can concentrate on area of interest. And this area of interest actually we call attention. Okay? And this is the particular neural network, the region proposal network, that the task of this neural network is to extract regions of interest, okay? And it makes speed up the process. And after that, we can do the classification, segmentation, whatever we want, okay? So very popular, and my students have several examples. I will show you some of them with Mascar CNN. These convolutional neural networks, most of them are in the RCNN and Mascar CNN and still very valid. The object detection neural networks are this YOLO Nano, several. And they're particularly for detection. Another are for segmentation. And this is old. I'm sure that every day you have so many new configurations. Sometimes the name VG 2014, and it's not the year, it's a number of layers that they use it, okay? Sometimes the name speaks. It's not the year. This is the number of layers, actually. So when we are trying to use these algorithms, we also measure the quality, not only with accuracy, but in the sense of segmentation, we are measured with dice coefficient. I'm not there. But these are the medical. If you have a medical studies, this UNet and DeepMedic, and they are particular for analyzing medical images. So if you have a questions for particular problem, I can give you advice what kind of neural network, deep neural network you need to apply for your problem. I'm giving to my students a lot of competitions, a lot of Kaggle competition. They participate. You will see some of the results here. And for the metrics, this is what I start mentioning, that for quality, how good is the segmentation? Is this area of the brain or every area of the image? We need, for example, to measure the intersect between the target and the what we get like result from segmentation. So I mentioned briefly in the beginning that for all of these deep learning models, actually, these deep learning models that I show, particularly with our mask CNN, they are using labeled data. So they need a labeled data. So somebody labeled this part, and after that we measure how good is our segmentation comparing with the labeled data. But some of the models, like one autoencoder, it's unsupervised, so not all of them are supervised. So this is another talk that I'm giving, and I will briefly introduce, because it's really important, the difference between the model that we trying to create right now and the brain functionality. So as you can see, the reinforcement exists, and there are a lot of models with deep reinforcement learning. Supervised, unsupervised, attention exists, but we're still not in the level of making associations, abstractions. So the main problem is that we need so many labeled data. So these are the articles that are giving you these statistics, that from statistical point of view, we need at least, so the neurons in the brain are 10 of power 11. So imagine how many images you need to have it or see it to reduce the error, because this is how the learning process is going. You minimize the loss function. So it's a course of dimensionality, because like we know from our experience and our children, they learn not seeing 10,000 images, they learn from 10 images or less. So there is another problem, and it's in this article, that actually the deep learning is expensive. And I don't know how the situation is right now in India with the internet and connections and all of this. But when I was there, it was difficult to run the models because it's actually energy consuming a lot. So it's expensive. So these studies say that one training session means that they are training sessions about natural language processing, particularly about the new model, the translating from English to Chinese. And for learning this, to train the model to translate every word in both languages, they need the energy consumption of 126 Danish home for 1 year, annual energy consumption. So imagine how expensive it is. So this is the future of research, that we want to develop models. And if you're interested, I will talk a little bit more about this. Models that are more simulating human and accelerating the computing. It's not just about the hardware, but we have to make changes in the models too. So all of this, its part is with how to extract the most important features in the environment. And this comes to attention. But before to go to attention, we have something that we call silency. So it's the information that is coming just from the image, and it's possible to extract. So it's what we call this bottom up, because it's coming only from original image, extract different kind of filters. This is the popular Koch model. He combined them, and we can say, okay, probably here is the attention, but this is the silency map. So the difference is, here is better to present. So bottom up, you are looking in the environment, and obviously you can see the cars, but when something is what we call task-driven silency, some particular task you have, or some accident or something, is a task-driven. So this type of silency is controlled from the our task, and this is what we call attention. So I probably you know Dr. Kunchev researches in compression, and we publish together several papers combining these ideas. One of them is, for example, when we're driving, we don't pay attention of background, okay? So our attention is mostly to the car and sign and some particular objects that are important for our task. So as you can see here, we compress the street 100 times, more than 100 times. This is the compressed image. This is the original. This is the compressed. You cannot see the difference, okay? But why we did this study was about the internet bandwidth, how people can transmit faster information. So, and they are doing right now too. Do you have these compression techniques for deep learning models? They are still valid approach of compressing, because you need to transmit the data that are important with high resolution, and what is not important, you can compress it, you don't care, I mean, and it still is visible. And this is the compression that Dr. Konchev, Professor Konchev and Dr. Koncheva created. So it's an inverse pyramidal decomposition. This is our joint patent. So we apply these techniques for medical images, and this is very appropriate for your students. I'm sure that I was impressed in India. The students are so active doing the apply research. They are doing competitions. They are trying to help people in the rural areas. So this is one example that, for example, for somebody with kind of skin problem, we don't know what kind of problem is this, and the person is far away from the hospital, so they can have an original camera. We are not using nothing special here. This is just a regular cell phone camera, but with our model, and it's obvious that you have a big difference between the texture and between the color. So you can immediately extract areas of interest. And this is one part of our study. But next part of our study is that extracting contours. Maybe you have it here too. Yes, but there are contours here. This is the active contours algorithm. But if this is in the hospital, the person manually needs to give the area of interest and start the contour. Our approach, because automatically define the area of interest, automatically extract the contour and transmit it, only the contour and this part of area of interest transmitted with high resolution, and the rest with low resolution. So the medical hospital can make immediately decision what kind of problem is this. So we apply for several research projects, like this was the skin cancer. This is another one with X-ray. We apply our attention. I'm trying right now with attention model to show you a little bit more. So detecting people, detecting cars, improving the quality of the surveillance. This is the project with Air Force. We have it. Again, attention in the sense of moving. So we don't care about nothing else, but we care about just the moving cars. Another problem, again, with attention, we use about video. This is my student in this city and around. We have actually 20 hospitals, and the city is not big. It's 300,000 people that are living here, but it's famous with the good hospitals. And in this hospital, they have a surgery video, I think 6 hours or something like this. I don't remember exactly, but they ask us to reduce the size of the video because it's too long to show people the most important parts and for the class. And they ask us to make a summarization. So what we do actually is finding out where is the big differences between the frames, and this is the threshold. So when there is a big difference, we keep the frames, only this frame, that they have a big difference between the content. Otherwise, we remove the frames. It's actually here, see? So from the whole video, we start to extract features with attention. So if there is really big difference, that's interesting. This is one of our recent work is using image captioning, is using both. So like I mentioned, and I'm certified instructor in natural language processing and computer vision, because right now both areas are integrated, and this is one example. So we have another, it's good ideas for your students. This project actually was awarded in business competition. My students participate. So when the kids are sleeping, the small children, year smaller than 1 year, so one medical doctor come and say, we have a problem with families that are not rich families, so they cannot afford to buy expensive equipment, but the child can die during the sleep. So they have several cases. And we make investigation that actually it's not good if you put the devices in the bed or next to the wireless devices next to the baby. So what we suggest, the option was to have an image or video remotely and monitor the position of they give us the parameters that we need to monitor, like baby position and how baby is covered. There are objects to cover or something else. So what we do, only from our image or video, we extract text. So this is the image captioning. And we extract, this text is extracted from us automatically because we have a deep learning model to do this work. And this text we send to the parents on the cell phone and doing alarm that something is wrong. So they don't need to pay attention constantly. It's very, very good. It was very good accepted, actually. They call it cloud care, because in this time, the deep learning model is actually in the cloud. So it's a service. But this can be done right now with edge computing without sending to the cloud. This can be done in the local cell phone or local equipment in your house, or something that your students can develop interesting projects. How I'm doing? I don't see any feedback of this. So we extend the visual question answering system for medical applications. This can be done for sport activities, for medical. My student is doing medical applications. And if somebody is interested, this is really very good for sport activities. So you can immediately say what is going on in this environment. So we do also X-ray images. And the problem will show you how these X-ray images, we replace the famous region proposal network with our attention model. This is how we replace it, actually. And this is the silent C that we extract. After that, making the box. How I am doing? Any questions? Okay, good, good. I need to see the feedback. I love to see the feedback. Yeah. Well, yes, a lot of. I even have more, but I don't want to. So we have a very big group working on facial recognition, and still is emotion recognition, still is very popular. With deep learning, without deep learning. But these people, for example, they're autistic kids. So again, from our hospital here, autism, depression, this is the collaborative work with Italy. So I work with my collaborators in Italy about depression. So now, again, people ask us to continue the depression. From Germany, I have collaborator. It's about pain. I didn't show this one. Security. We did actually with Indian students. This is why I put this image here. We did a study with my Indian. We have every summer, we have Indian students for summer internship. So we have to talk in the end of this, if it's possible to do it. So they create, on the base of our previous research about movements of the eyes, very simple idea, if you close the eyes, or if people are sleepy or stressed, or they add more parameters, but they monitor the behavior of the driver. And we went to truck companies, and the truck companies monitor every part of the vehicle, you know, the engine and everything, and they don't monitor the most important part, the driver. So we don't know what will be in the future with the self-driving cars. But anyway, this study was very well accepted. Another very interesting problem is with chatbots. So the chatbot also, my students in competition, they receive first award in governance competition. For I have a video here. Some if we have time, so I can show you the video. But the main idea is that you type text like a chatbot, but with computer graphics generated avatar. So, and the avatar answer the questions and express emotions. No. Okay, if you want, I will come back and show you. Let's see if I can. No, this is the paper. I'm not sure that I didn't check this. Maybe not. No, this is the competition. I'm sure that I have it somewhere. Can show you. So we did also the very popular right now. From several students are working on if somebody use your image, or if it's a computer generated face or computer generated, this is the fake news, fake images, fake videos. And we published the study that actually when people trying to create virtual fake image or video, they are not so good expressing emotions. So in the emotions, you can see the differences. But this is the famous from deepfake. So you have studied about attention in joints. Attention is first our skeleton that we create. It's our skeleton. We were able to create it from, again, finding the important parts of the body, like features, and after that combine them. Why these previous studies we use recently for Singapore? I have a contract. You see that I have several contracts, but the contract with Nokia Bell Lab was with Singapore facilities not to figure out when people are falling down, but to prevent falling. So can we monitor, and right now we have several tasks about preventing cognitive disorder, preventing depression, preventing falling. So for this task, preventing falling, we need to figure out the changes in the gait movement during time. So it's not only one day. So we create in the lab monitor camera and monitor the gait of person during 6 months. So, and actually we figure out that they improve and I improve my gait, because there is a sign if you're doing good or you're not doing good. And I think that I have here the configuration. Okay, so it's this is the camera. We're walking, and we can make extracting features. With this case, we use very famous open pulse. Okay, all of these are deep learning models that are free. So this open pulse is free. You extract the skeleton automatically, not like before, and from there you actually calculate the movements. This is my student. We have also experiment and data set. If it's normal walk, or we put some kind of weight here on the leg and make up normal, but in different conditions, and to see the changes, how we can figure out the changes of normal, abnormal weight walk, and monitor the gait and extract the falling parameter. I have the article several about this falling risk. So this task also is integrated with the parameters that we have for this person. So first is to detect, separate the person. After that is every day measure the blood pressure or several medical conditions and edit these conditions to the gait condition. Okay? So I'm almost in the end of all of this, because there is a marketing study that in 2040, so not it's near, it's less than 20 years, 19 years. So we will have the artificial intelligence, what we call general intelligence, that actually will reach the human intelligence. So, and after that, we will have a super intelligence. And it's not like in the movies, it's a lot of talks, probably you listen them also, that we are really very responsible right now how we will create it, because it's kind of we're responsible how we create it, because if they have intelligence better than us, we don't know how these agents, whatever we call them, will perform. So this is really scary for people, but a lot of responsibilities. And I know that you probably see many times this image that we are in the fourth industrial revolution right now. So, like I say, this is another my talk about what is the problem with deep learning. Like I start in the beginning, we ask the child what is in the image, and the child will say yes. We can train the model, and the child also, we can say that it's umbrella and elephant. But when you ask the child, or everybody asks, okay, is this umbrella good enough or big enough to cover the elephant from the rain? So the child will answer no, the umbrella is not big enough, it's not covered. So this kind of making a decision, the deep learning cannot do it. And I'm sure that cannot do it right now. Okay, so the deep learning in the sense of what they are right now, just segmentation, just extracting objects, but cannot make a decision appropriately. So they are, like I say, in the future studies, and right now in the future I have presentations, and my future work is actually related with this aspect. I'm very interested. And the paper is here, one of them, that we need actually not only to concentrate on the brain like before and how we simulate it, but we have to figure out the properties of the word. So we have to find this drawing representation feedback. Okay, so I will have a look. Well, I mentioned we have a drawing representation, and you see in this deep learning visualization toolbox in the brain drawing representation of the environment, but in the same time, we need to match this presentation with symbolic representation. Okay, so the natural language and symbolic representation of the word, it's guiding us, like in the sense of, for example, baby captioning, or any, what kind of example to give you, like if it's a bird flying, obviously we will search bird on the top of the image, not in the bottom of the image. So the natural language symbolic representation, graph representation will help us to interpret the drawing that we extract in the pixel level. So the pixel representation, like we see before, we need to integrate with symbolic representation. This is in general, but it's a good paper. Maybe somebody already. Okay, so this is what we needed. We need to figure out really advanced algorithms, but be careful what we create in the future. But of course, not ignorance, not skepticism, and stuff like this. So the next one is my presentation about the NVIDIA that I will go in and show you. Do you have any questions about this part of the talk? I saw some. Okay. Well, this is end of my research part. I will go after that to different topics.
Madam, you can go to the next topic.
Okay. What is in the link? Do you need this link, or I need this link or not? Okay. Okay. Thank you. Thank you. So when I talk about all of these deep learning models, I present what we can do with deep learning models, because otherwise, I'm sure, I mean, if I know what is your task or task. So like I mentioned, I'm an ambassador and certified instructor of NVIDIA. My mentor over there is Joe Bungo. So in this presentation, you will see many links. So the main link is this one, deep learning.
Here, I want to request all the faculty members to listen this portion very carefully. Those who are working in this area will get plenty of resources and links from this presentation. Please continue, madam.
Yes, sure. So the Deep Learning Institute offers a variety of courses. Some of them, most of them are actually online courses. We also offer the workshops, instructor leaded. We'll show you several teaching kits. So the main web page is this one. So the workshops are in enterprise solution. Well, we have for Jetson Nano, some of them. So what is the advantage to become a certified instructor? You can give all of these courses for free. Okay? Otherwise, you have to pay $90. So for example, for getting started with deep learning, some of them are free. For example, this one is very good, getting started with Jetson Nano. The Jetson Nano, last one was like $57, I think, or I bought it for $99, but I think that is cheaper now. And the certificate is free. Let me check this one. Yeah. So you can enroll. All of this is in, you go to NVIDIA server. If you want me, I can go, but first let me show you the idea. This is the free one. Oops, I closed it. We will go back again. It's kind of confusing because you have so much information here. But the main, like I say, is actually online classes, workshops, and teaching tools. So these are the workshops that are offered right now. So there is one building intelligent recommendation system. There is one with CUDA, another one. This is the fundamental of accelerating, like I say. Let me show you the video. This is the instructor lead workshops. So you can become a certified instructor, and I will show you how. But let me show you the video. Now my computer is so slow. When I have the...
Through the NVIDIA Deep Learning Institute, you can get hands-on training in AI, accelerated computing, and accelerated data science. The remote workshops can be accessed from anywhere and are powered by workstation-class GPUs in the cloud. All you need is an internet connection.
Good morning. Welcome to today's DLI course. We're glad to have you here.
Workshops are led by DLI certified instructors that bring real-world experience into the virtual classroom.
Neural network complexity is exploding.
Sessions include a mixture of instructor-led lectures, whiteboarding, and interactive coding challenges, which help students learn theory while gaining hands-on experience. Quizzes throughout the course also help gauge students' understanding of the material.
Wow, you guys are doing great.
And the platform makes collaboration a breeze. Private rooms give students one-on-one time with the teaching assistants.
Does anybody have any questions? Let's just take a minute here and see.
Public chat rooms make discussions with the whole class possible.
Great question. Does anyone know how to choose an optimal batch size?
You can even raise your hand to get the instructor's attention. In breakout rooms, students can meet with the teaching assistants individually or in groups to dive deeper into the content.
Hi, everyone. Welcome to the breakout room.
You can even share your screen to troubleshoot problems live.
I'm actually having trouble running the training scripts.
Okay, great. Let's take a look at your code.
Every course ends with a comprehensive coding assessment to verify students' knowledge. A successful completion can earn a certificate of competency to support professional growth. With instructor-led remote workshops, the Deep Learning Institute is helping to make world-class learning experience possible from anywhere.
Thank you for attending today's CLI course. We'll see you next time.
To learn more, visit nvidia.com/DLI or email us at nvdli@nvidia.com.
Okay. Yes. So this is the workshop. So they have, I will show you the topics in the end. They have all of these problems resolving, and I mean, they have a GitHub link, links, many, and I will show you them. So the interesting part is that you have to become a developer, and it's free. You can do the certificate. Actually, even my students push them, and 2 of them already are certified instructors. And you can become a university ambassador. So in these workshops that you see, usually they are long, maybe 6 or 8 hours, because we have not only to present not only theoretical part. I can do with you maybe for 4 hours, I mean, for your students. But they need to have a laptop or computer, not some of the students from India, they participate with cell phone, but it's kind of difficult to work coding part, because there are coding parts hands-on. It's not, it's using Python. All of this, like they mentioned, you need only the internet, because you don't need to, everything is Python notebook, and the execution is on the server. But what is interesting also, you can download it, the code, and use it in the future with your data set. And my students also upload to the NVIDIA server new code and run it, and I mean, it's very useful. So these are the online training. I can give you the code for one of them, for example. So for what this brings to teaching, how this helps us, actually helps a lot. The solutions are very applicable. It's free software, computing resources and hardware, all of this is available, saving time for preparing. These are the teaching kits. They are really very interesting. They are teaching kids about robotics, about deep learning, and another one is new. So let's go there. The teaching kits, I can show you. They are coming with instructions you can use in your and kit ebook. they're coming with instructions with PowerPoint presentations. I can show you some of them if you want to. Accelerating computer is new. I know some of these people that are creating this. It's with Rapids, a new machine learning library. It's similar, as you can mention, probably somewhere here. Parallel computing, because it's using Rapids, these people. It's similar of scikit-learn library, but for parallel computing. See, this is the Rapid. Rapids are very famous right now, libraries. Another one is deep learning. Another one is robotics. This robotics is with Jetson Nano. It giving you idea about how to you can use with different sensors. Right now we are applying for cybersecurity, for example, this one. In the beginning was with computer vision, so it's detecting, recognizing objects, stuff like this. Okay, this is for teaching kids. I can show you if you are interested what is the content. Like I say, it's a PowerPoint presentations, exercises, exams, and Python code. Okay, this is for Jetson Nano. They have a lecture about path planning, okay, localization, control, and obstacles avoidance. So it's coming with the platform, a lot of courses. This is the new one that I'm waiting to see in August, teaching kids. Okay, so yeah, accelerating with Rapids. Yeah, so you can, I want to show you this process actually. You have application process. Just click on the link and see the application to apply for ambassador and for certificate. So what is the idea? First is apply. After that, you have to do the course. I mean, it's a Python course. You have to finish, completed the course. After that, it's an Instructor platform course. And you can get the certificate. But in the end, you actually have to talk with the instructor. It's kind of exam, face-to-face exam, to check the theoretical knowledge that we have. And so there are three phases, as you can see. First is to apply. Second is to take all of these exams. And third is to have a face-to-face exam to get the certificate. But the advantage is that actually all of these workshops, if somebody wants to participate, and here in San Jose, for example, I was in the workshop with at least 300 people. A lot of people are interested. It was not so expensive. Right now, people pay $500 just to participate in workshop. But if you become a certified instructor or ambassador, or you can have a certification to give these workshops, this is free for your people. Because we're a university, if your company want to become a certified instructor, you have to pay this money. But for us, for university educators, it's free. So, of course, you enter in the community. My experience, like they say here, opportunity to run pay, okay, this is true. To run pay DLA training for industry. yes, this is they offer actually possibility for us to run the workshops for industry. Actually, it's not good payment, but anyway, they probably will increase it. But when my students in my university offer this kind of workshops, the industry partners accept us very well, in the sense of they are willing to collaborate with us, that we're more apply oriented. So it's good for instructors that you have already free access to a lot of useful material in the class. And it's good for the students that they can get a good job. Okay. Yeah. Students training for future job. Our example. University resources, I've already shown you. Okay. To go to, and these are the different solutions. Okay, maybe the topics. So they are also offer some, you know, the learning to Amazon server, how to do the Docker. So this is get started with NVIDIA Docker. My students are using. We first use digits, and you can download it from GitHub. But I need to show you the developer link. This is for from the last conference topics. You can go and whatever is your interest, if it's a healthcare, for example, you can go and see what the talks are related with healthcare. Subscribe, and you will see every day they will show you some kind of webinars, giving you the links. Let me show you the developers links. This is from so these are the projects from constantly they do the competition, and this is the Jetson community project. So with this, like I say, it's a free course, and the Jetson it's very cheap, and it can do the skeleton, can do all of this stuff. not so impressive, but I can show you the more impressive from my students, that they actually, the robot speaks. The robot can tell you what exactly is in front of the robot. So I have better video. This is just from them. But as you can see, the examples are several examples. This is one with the exercise, doing the exercise, the guy. So these are people, developers that are exchanging ideas. I see this one with exercise again. And you see, they have a blog, they have a code, they show you what exactly they are using. I don't know exactly what is this, but sure. So I think that this is very useful for your students. I'm using constantly. So constantly giving the, okay, I don't want to close this one. Giving the projects this one. So the only thing that you need to do, also this is detecting them. And this is what we're talking about, the attention part. Yeah, you can use different camera. For example, this is the thermal camera. See, you have the video, you have the code, you have a blog, you have the discussion. This is, I think, is the advertisement.
Hi, I'm Thomas. I'm a master's student of computer engineering at San Jose State. And today I would like to tell you more about the projects we are working on. So the first project is an AI thermometer. It is a device that's based on an NVIDIA Jetson nanocomputer and has an RGB and infrared camera on board. Using the RGB camera output, I'm able to run an object detection neural net and get the precise locations of objects in the image. Thanks to the infrared camera, we can tell with a certain degree of accuracy what is the temperature of the object. Right now, I'm going to power on the device and plug it into a monitor so you can see how it works. Right now, you can see the view captured by the AI thermometer. On the left-hand side, you can see the images with bounding box overlay from the RGB camera, along with the detected class, the confidence score, and the temperature in both degrees Celsius and Fahrenheit inferred from the infrared image. On the right-hand side, you can see a colored video from the infrared camera, where the areas in red correspond to the hotter spots, and the areas in blue to the cooler ones. As you can see, the icy water inside the glass is cold at around 37 degrees Fahrenheit, whereas the mug, where the warm drink inside, is pretty warm at around 160 degrees Fahrenheit. Measuring the temperature of common objects is interesting, but the really useful application is measuring the temperature of the people in the image. Deploying the AI thermometer at the entrance to crowded buildings, such as schools or airports, can provide an efficient screening for fever, which is one of the most common symptoms of viral diseases.
Okay, we go back. Okay, I have many of them. So you have to go to this link. I mean, this is developers, I think, or education, and what I show you at the beginning. But for companies, these are for the companies. But I think that the developer link is really very useful. And like I say, if you want me, I can do the workshop, or you can just let me know what kind of course is interesting for you, and I can give you the code for this discount. free code. So I think that's it. I mean, there is a talk. We first investigate what you really want to do, but in the same time, I want to encourage you. Go and apply. You have the link here for the application. Apply for because will be beneficial for all of your students and will be beneficial for your university. Okay, if you have a people. No, not okay. I can send you the link again. But will be very beneficial for your faculties, for teaching kids, for certificate. This is the email of another person. So this is for me from now.
Thank you, madam, for the excellent presentation, as well as giving an information about the NVIDIA products and the services which is available for the teachers.
Yes.
I'll request you to share this PPT so that we'll share among the teachers.
Exactly.
They will be going through the slides, and which is applicable to them, they will apply.
Exactly. So if you have a problem, just let me know for the links and apply. Yes. I will send you immediately. So I think I showed this already.
Yeah.
Okay.
Okay.
So,
and Mr. M. Thangavel has raised the hand, whether he is from our university or from NVIDIA. Okay. So, is he interested to ask something?
Yes.
Okay. So now the forum is open for question. There are a lot of things the teachers may be interested to know, and now it is open for them.
Maybe they, when they see the links, they will learn a little bit more.
Correct.
Contact me.
Yes.
Please, anytime. There are many opportunities to get the kids and use it. Many opportunities for me to teach you online. Maybe we can do very short, for example, for 1-2 hours, instead of just talking about the project's particular topic. That course, online course. Check the online courses.
Yes.
Because they are short, or any course that you are interested, just let me know. Or maybe we can have not only one, we can have 2 or 3. Just let me know what is interested about natural language. Or first always we start with fundamentals of deep learning, because the people needs to understand how to work with deep learning, and after that start with applications.
Correct. So if there is no question, then
Shrikant sir, excuse me, I have one question.
Yes, welcome.
Wonderful.
Ma'am, good morning, ma'am. I work with deep learning algorithms for image segmentation and image denoising, basically. These 2 areas I have covered. I wanted to know, ma'am, does your group, like you work with electron microscopy images by any chance? You showed a lot of applications like cloud care and instance segmentation, a lot of areas actually. Do you work with denoising and denoising using deep learning in electron microscopy images? I work with metal microstructure images denoising. So, and I have used deep learning for that.
Yeah. Not exactly with these images, but we work with X-ray and multispectral. So I don't know how far away your images, you can send me. What we like for denoising is autoencoder,
Yes, ma'am, autoencoder.
Autoencoder is good. And what I suggest you can send me email. You have my email in the end. Right now, there is one, when you are denoising, is exactly what I talk about, is how to find the statistical property of the noise comparing with the good data. So there is one dynamic mode decomposition technique that I really recommend you. Just write down dynamic mode decomposition and is implemented in some deep learning models. So we're trying to figure out better way, and you're correct. Autoencoder is one, but depending what kind of autoencoder. I really think that, yeah, or maybe sparse decomposition. So different decomposition technique will help you better. But
Okay.
you can send
Okay,
me
ma'am.
the.
Then I can send you some samples and
We can definitely.
communicate
This
through
is
email. Yes, ma'am.
very,
Thank you,
very
ma'am.
interesting. Yes, very interesting task, and is for many, many problems like a ultrasound, like you have in the water image. In all of these images, you need to
Underwater image.
underground. Exactly. So all these images, you have the same problem. And actually, many years ago, my PhD was modeling the noise in ultrasound.
Okay.
But we send me the images and we will talk. But thank you for the question. Very good question.
Okay, ma'am. Thank you, ma'am.
Any other question? Okay, Bharat, can you now start vote of thanks formally?
Yes. Definitely. Yes. I also thank you, Professor Bharat and Professor Shekhar. Thank you so much because it's so late, and thank you for everybody to participate in Saturday. Thank you so much. Okay, keep in touch. I will send you.
Namaste, namaste from India.
Thank you. Bye. Bye.
Bye.